Hi everyone. In this video, we are going to discuss about the transformer basic parameters with the help of transformation ratio. So let me start with the basic diagram, construction diagram of a transformer. And this is a transformer, single phase transformer with primary number of turns is higher than the secondary number of turns, which shows the transformer is a step down transformer. So the given transformer which we are seeing here is a step down transformer because number of primary turns is greater than number of secondary turns. So this is step down transformer, right? If number of primary turns is less than number of secondary turns, then the transformer is known as step up transformer, right? This is step up transformer because here the number of primary turns will be lower and the number of secondary turns will be higher here, right? So similarly, primary voltage for this condition, for step down transformer, primary voltage will be greater than the secondary voltage. Here P and S, suffix P and S in all these parameters represents primary and secondary. P means primary, S means secondary, right? So in this case, Vp will be less than Vs. Primary voltage will be less than secondary because this is a step up transformer. So secondary voltage will be higher compared to primary voltage. So we already know the basic principle of transformer. If we give supply to this primary side, if we supply or we energize the primary side, number of windings or number of turns, primary number of turns with alternating supply, then a flux will get induced in this iron core, and its red color dotted lines indicates the flux linkages or flux lines which is passing from primary to the secondary number of turns, which will induce an EMF in the primary side, which will create a current which will indirectly induces the magnetic lines in the secondary windings, so that it will create a EMF, induced EMF. Through that, the secondary current IS will flow through the load connected across the secondary winding. So this is the basic principle behind the transformer. So with the help of this number of turns and voltage expressions, we can derive the current expression, that is in step down transformer, number of turns and voltage and induced EMF, these three parameters will be same, whereas the current I will be inversely proportional, right, in this step down case and in step up case. Let us write this with the help of transformation ratio, that is, it is represented by the transformation ratio is represented by the parameter K, which is equal to Ns divided by Np. Ns means secondary number of turns divided by primary number of turns is equal to Vs divided by Vp, secondary voltage divided by primary voltage, which is equal to Es divided by Ep, that is secondary induced EMF divided by primary side induced EMF, which is equal to Ip divided by Is, that is primary current divided by secondary current, right? So these parameters, that is number of turns, voltage and induced EMF, these three parameters will be inversely proportional to the current, right? So this is the relation. This can be also written as K is equal to N2 divided by N1 is equal to V2 divided by V1 is equal to E2 by E1 is equal to I1 divided by I2. This can be also written like this, right? So with the help of this transformation ratio, let us solve a few problems related to this parameters. I mean N2, N1, V2, V1, E2, E1 and I1, I2, right? So to start with, let me assume that primary number of turns, I have 1000 turns. Let us assume that primary has 1000 turns and secondary turns is equal to 500 turns, right? Now this is a step down transformer because primary has 1000 turns and secondary has 500 turns, so this is a step down transformer. And I also know the primary voltage which is 100 volt, but I don't know the value of secondary voltage. I need to find the value of secondary voltage. Secondary voltage is equal to, I need to find the value of it. So with the help of this relation NP or NS divided by NP, secondary, I am going to ratio the value of secondary number of turns to the primary number of turns. NS divided by NP is equal to Vs divided by Vp. I need to find the value of secondary voltage. I know the value of primary voltage, primary number of turns and secondary number of turns, but I don't know the value of secondary voltage, right? So from this I can write, I need to find the value of Vs, so I can rewrite the above expressions. Vs is equal to Vp into Ns divided by Np. So where primary voltage is 100 into Ns is secondary number of turn is 500 divided by primary number of turn 1000. So when I cancel this, I will get 500 divided by 10, right? So which will be 50 volt. So secondary side voltage is 50 volt. So primary is 100 volt and secondary is 50 volt, because this is a step down transformer, because primary number of turns is 1000 and secondary number of turns is 500, so which is 2 times lower. So if I give 100 volt in the primary side, I will give 50 volt at the secondary side, because this is a step down transformer, right? So let me solve a problem to find the value of current. So primary voltage Vp is equal to 100 volt and secondary voltage Vs is equal to 50 volt. Primary current Ip is equal to 2 amps, and I need to find the value of secondary current Is is equal to, right? So I need the value of secondary current. So to find this, I am going to relate the voltage with current. I know the value of voltage, but I don't know the value of secondary current, but I know the value of primary current. So the expression is Vs divided by Vp is equal to Ip divided by Is, right? So I need to calculate the value of this. So I am going to rewrite this expression. So I will get Is is equal to Ip into Vp divided by Vs. So which is equal to primary current is 2 amps into primary voltage is 100 divided by secondary voltage is 50. So I will get 200 divided by 5. So I will get 4. So Is is equal to 4 amps. The secondary current is 4 amps, whereas the primary current is 2 amps. So we already know that the transmission ratio of transformer is, the current is inversely proportional to the voltage. This is the principle behind the transformer, right? So if it is step down transformer, the current will be higher. If it is step up transformer, the current will be lower, right? So with the help of this case or this problem, we can justify the answer that the current, this is a step up transformer with 100 volt primary, sorry, step down transformer with 100 volt primary and 50 volt secondary, but the current in primary is 2 amps, but the current in secondary side is 4 amps, right? So these are the basic parameters of transformer with respect to number of turns, current and voltage, right? Thank you.